Okay, in graphification or representation of complex number, this is how you are going to graph them. Okay, if you have a complex number like this, we have both the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant in complex number representation. This representation of complex number is done on a rectangular plane that have coordinate axes of x and y, where the general form of complex number is represented like this: x plus iy, where x is the real portion and y is the imaginary portion. So if I want to represent where both of them is positive, which quadrant do you think it falls to? The 5 is representing the value of x, which is the real. So 5 will be 1, 2, 3, 4, 5. 5 is along here. Then 4 in imaginary, which is positive y-axis, will be like this: 3, 4. Okay, so 5 and 4 will be meeting somewhere here, where I have this point. So both of them are meeting in the first quadrant. The first quadrant, which here is 4 and here is 5. Then the modulus is R, or what we call absolute value of z. Okay, this is the graphical representation of this complex number. If I want to take care of this one, discover that we have negative real, which is negative x. I have negative 1, negative 2, dot dot dot, negative 5. Negative 5 is somewhere here. Then we are talking about positive 6. I have 1, 2, dot dot dot, 6. So 6 and negative 5 is meeting at the second quadrant. Where the modulus is somewhere here, the R, or the absolute value of z. I'll take time and teach you modulus. Just know the graphical representation of complex number, so that it will help us in finding the argument or reference angle theta of a complex number. So when you note this, you'll be seeing that here is 6 and here is negative 5 in the red. Okay, if you have the one that you're having z to be equal to minus 4i, minus 4 minus 5i, all of them is negative. You'll be having minus 4 in the real, and the real with minus 1, minus 2, minus 3, minus 4. This one is minus 4 in the imaginary, which is in y, negative y-axis, minus 1, minus 2, minus 3, minus 4, minus 5. Okay, so minus 4, minus 5 will be meeting on the third quadrant, and the modulus is always coming from the origin, where I have here to be minus 5 and I have here to be minus 4. Okay, the R, which is the modulus, comes here. Okay, if you want to graph this complex number, we're having 6 minus 5i. So 6 is in the positive real axis, which is somewhere here 1, 2, dot dot dot, positive 6, and the negative imaginary, which is minus 1, minus 2, dot dot dot, minus 5. Okay, so positive real and negative imaginary is meeting at the fourth quadrant, which I have my modulus always running from the origin, where I have here to be negative 5 and here to be positive 6. If you are given a complex number and you are asked to find the argument is represented with z or theta, which is have the formula of tan inverse of y all over x, where y is the imaginary and x is the real. Okay, if you have example 1 to be z equal to 4, for example 4 minus 3i, okay, let me use plus, first quadrant. Okay, if you want to find the argument of this complex number, one will be tempted to do something reasonable by having z to be equal to tan inverse of the 3 is the y and x is 4. So if I take the tan inverse of 3 over 4, I will get the theta or the argument of this complex number. So example 2, if you have a problem like this, you have z equal to minus 5 minus 5i, for instance, and you are asked to find the argument of this complex number, one would be tempted to have that z is tan inverse of y is minus 5 all over x is minus 5, which will give me tan inverse of 1, and tan inverse of 1 is 45 degrees. Okay, 45 degrees is not the final answer for this argument. Why? Because the graph of this complex number did not fall in the first quadrant. So if you graph it, if you graph this complex number, you discover that since x is here and y is here, and x is minus 5. Minus 5 is minus 1, minus 2, dot dot dot, minus 5 here, and the negative imaginary is minus 1, minus 5, somewhere here. So both of them are meeting in the third quadrant. So the formula of calculating reference angle in the third quadrant is 180 degrees plus theta. And z, formula of calculating and z in the third quadrant is 180 degrees plus theta, which I have my theta to be 45 degrees. I'll be having 180 degrees plus 45 degrees here. That my final answer for reference angle at z to be 225 degrees. Okay, let's take two more examples on argument of complex number. When you are having 3 to be, if you contain something that looks like this, z equal to equal to 3 so 2 all over 2 is positive, we have negative 3 so 2 all over 2. Okay, I have asked to find the argument. The argument of this complex number, which is at z will give me tan inverse of 3 so 2 all over 2 divided by, this is negative, divided by 3 so 2 all over 2. Okay, so when we do it, we have equal to tan inverse of this divided by this will give me 1. So tan inverse of 1 will give me 45 degrees. So because the imaginary here is negative and the real is positive, you have to check the quadrant that is belonging to. By graphing the function, when you graph it, you discover that in quadrant here is my positive and the negative imaginary. Here is my positive real and the negative real. So anytime the imaginary is negative and the real is positive, that means it falls under the fourth quadrant. And the formula of calculating the reference angle or the z in the fourth quadrant is 360 degrees minus theta, which I have 360 degrees minus theta is 45 degrees. So we'll be having 360 degrees minus 45 will give me 315 degrees. So this is the actual z.
I beg, now we don't watch and share like just like comment. I did just beg you, comment now. Why you do that? You start. You want to go?